Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 6, Permutations, Combinations, and Binomial Expansion, brought to you by Vitan Sir. Dear students, previously we discussed the concept of binomial expansion, in which we studied the method of expanding binomial variables. For example, a plus b whole raised to 2 whole raised to 3 we already knew, but how it actually happened, and using the same method how can we expand power 4, 5, 6 or 7? That's what we studied in the previous tutorial. Now in this tutorial I'm going to start with exercise 6.3. Now this is a very small exercise in a way because there are only 5 main questions, but all of these questions have some sub questions which has a long method. So out of the 5 main questions in this tutorial I am only going to complete one question with 5 sub questions. Okay, so this will be a bit of a small tutorial. Question number 1, obtain the expansion of following binomial expressions. Now there are 5 sub questions to this particular question, and that is what this tutorial is going to be of. First one, 3a plus 4b whole cube. Now our system is first write down all the coefficients and then start with the first term and then the second term. So the coefficients for the power 3 are 1, 3, 3, 1. Now after doing this we have to start with the first term, which is 3a. So starting with the maximum power here, 3a raised to 3, 3a raised to 2, 3a raised to 1, 3a raised to 0. So from maximum to minimum. Next we start with the second term here, that is 4b. So 4b will start with the minimum power, that is 4b raised to 0, then start with increasing order 1, 2 and 3. So once we are done with this, because there is a positive sign here, everything will be positive. Now we simplify this. 1 doesn't matter whether we write it down or not. So 3a cube, 3 cube is 27 and a cube is a cube. Because this is raised to 0, I am not going to write anything here. Plus, now 3 will be 3, 3a square, so 3 3s are 9, a square, and 4b raised to 1, so just 4b, plus 3 will be 3, 3a raised to 1 is 3a, and 4b raised to 2, 4 square 16 and b square, so 16b square, plus 1 will be 1, 3a will raised to 0 is 1, 4b cube, so 4 cube is 64 and b cube. Now we will simplify this step further. 27a cube will be that as it is, 3 into 9 into 4 a square b. So 3 into 9 into 4 is 108 a square b, plus 3 into 3 into 16 144 ab square, plus 64 b cube. Now this was a very easy one. So this is how we expand our given terms. I bet you have never done something like this before in your earlier standards. What we used to do was simple expansion. Now this is somewhat complex expansion, but this is just the beginning. 1 plus x whole raised to 7. Now because the power is 7 here, I am going to write down the coefficient of the 7th power, that is 1, 7, 21, 35, 35, 21, 7, 1. Now this is going to take a lot of space, so I have written it in smaller size. I hope you guys can read it properly. Now 1, first term is 1 itself, so power 1 raised to 7, 1 raised to 6, 1 raised to 5, 1 raised to 4. This dot is multiplication, okay, don't misunderstand. 1 raised to 3, 2, 1, 0. But actually it does not matter what is in the power of 1, the answer will always be 1. So 1 raised to 7 is also 1, and 1 raised to 0 is also 1. Multiplied by the second term, we will start the second term with power 0, then 1, 2, 3, 4, 5, 6, 7. And because there is a positive sign here, all the values will be positive. Now, this 1 and 1 doesn't matter whether we write down or not, and x raised to 0 is also 1. So the whole term here is just 1 plus 7 into 1 doesn't matter into x, so 7x plus 21, 1 is just 1, x square, so 21x square. Similarly, 35x cube plus 35x raised to 4 plus 21x raised to 5 plus 7x raised to 6 plus x raised to 7. All these ones we can omit. It is not necessary to write them down. We can just ignore these 1 values, 1 raised to 3, 1 raised to 4 and all that, and we just write the values which are not 1. Here we have to write 1 because only 1 is there, no other value is there, so just 1 is compulsory to be written. So this is the second one. Question number 3. Now we start with a bit of difficult sums. 3 upon x minus 4x upon 3 the whole raised to 4. Okay, let's start expanding this. Because the power is 4, my coefficients will be 1, 4, 6, 4, 1. Then the first term is 3 upon x raised to 4, 3 upon x raised to 3, 3 upon x raised to 2, 3 upon x raised to 1, and 3 upon x raised to 0. Second term, 4x upon 3 raised to 0, 4x upon 3 raised to 1, 4x upon 3 raised to 2, 4x upon 3 raised to 3, and 4x upon 3 raised to 4. Because there is a negative sign, this first term will be positive, then negative, positive, negative, positive. We will simplify it one by one. We will start with this. 1 and raised to 0 is 1, so this will be ignored, and 3 upon x raised to 4. So 3 raised to 4 is 81 and x raised to 4 is 4 minus 4. 3 upon x raised to 3 is 3 3s are 9 3s are 27 upon x cube, and 4x upon 3 raised to 1 is just 4x upon 3 plus 6 into 3 square 9 upon x square, and 4x square is 4 square 16x square upon 3 square 9. We have to make a square of all values. Minus 4 3 upon x just because raised to 1 is there, 4x upon 3 raised to 3, so 4 into 4 into 4, 64x cube upon 3 3s are 9 3s are 27 plus 1 is there, 1 is there, and 4x upon 3 raised to 4, that is 4 raised to 4 256, x raised to 4 upon 3 raised to 4, 3 3s are 9 3s are 27, 3s are 81. Now to simplify this, 81 upon x raised to 4 minus, now what we can do here is this 3 will be cancelled against this, x will be cancelled against this, so 4 multiplied by 9 multiplied by 4 upon x square, that is 144 upon x square, plus 9 9 cancel, x square cancel, 16 6 are 96, minus x against x cube cancelled, so x square will remain, 3 against 27 cancelled, so 9 will remain, and 64 4s are 256 x square upon 9 plus 256 x raised to 4 upon 81. So now this is your expansion of the term 3 upon x minus 4x upon 3 the whole raised to 4. What you need to do here, remember one thing, the power values when you open the bracket, all the values in the brackets must be uh, simplified according to the power, number one thing. Number two, whenever these fractional values are there, don't forget to cancel them among each other and get the minimum possible value. Okay, don't just multiply this value directly, cancel them first, okay, for all these values, and get the minimum possible value here. Third thing, whenever there is a negative sign here, give the signs alternatively, plus minus plus minus plus. If plus is here in the question, then all the signs will be positive, but if negative sign is there, alternative plus minus values should be given. So this is your expansion for the third one. Fourth question, root x upon 3 plus 3 upon root x the whole raised to 6. Okay, because there is the power of 6, the expansion here will be 1, 6, 15, 20, 15, 6, 1. I have taken it to the extreme values because this is going to be a long expansion and I can't make my fonts smaller than this. It will not be readable. Now first one is root x upon 3. So root x upon 3 power 6, root x upon 3 power 5, root x upon 3 power 4, power 3, 2, 1, 0. Next, second term 3 upon root x power 0, 1, 2, 3, 4, 5, 6. And there is a positive sign, so plus, 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 and plus. Now, first thing you should notice that root x upon 3 and 3 upon root x are inverse of each other. That means we can cancel them out with each other depending on their powers. For the first term, the power of root x upon 3 is 6 times and 3 upon root x is 0 times. So this is just 1, this is also 1. So we will be left with root x upon 3 whole raised to 6 plus. Now in this case, root x upon 3 is 5 times and 3 upon root x is 1 time. Because it's inverse, we can deduct 1 from 5 and we will be left with 6 root x upon 3 raised to 4. 5 minus 1, because it is inverse, we can cancel them. So 5 minus 1 times, so 4 times will be remaining. Plus, this is root x upon 3 4 times and 3 upon root x 2 times. So again, when we remove 2 from 4, we are left with 2 times root x upon 3. So 15 root x upon 3 raised to 2. Here both of these values are 3 times, they will cancel each other out and we will just be left with 20. Now this time 3 upon root x has a greater power. So these 2 will be deducted from 4 and 3 upon root x will be there with power 2 plus root x upon 3 is 1 time, 3 upon root x is 5 times. So 5 minus 1, 3 upon root x will be there with the power 4 multiplied by 6 coefficient value plus, now here 1 raised to 0 is 1, so 3 upon root x is directly there with power 6. Now we start with simplification. Whenever root is there, the power is divided by 2. That means if I want to make a power of root x with 6, so if I remove the root, the power will be half. Because it's root, the power will be half. So root x raised to 6 will be as good as x raised to 3. So x cube upon 3 raised to 6 is 729 plus 6 root x raised to 4. So when I remove the root, 4 becomes 2. So x square upon 3 raised to 4, 81 plus root x raised to 2. So when I remove the root, 2 becomes 1. So x raised to 1 is just x. So 15 into x upon 3 3s are 9 plus 20, no change there. Now here 3 square will be 9 and root x raised to 2. When I remove the root, it just becomes 1. So 15 into 9 upon x. Similarly, 6 into 3 raised to 4, 81 upon, when I remove the root, 4 becomes 2, x square plus 3 raised to 6, 729 and root x raised to 6 is x cube. So just remember, whenever root is there, the power becomes half. So when you remove the root, you just have to take half of the original power for the purpose of calculation. So this is still not the final format, because here we can cancel out 6 with 31, 3 is common, so 3 2s are 6 and 3 27s are 81. Similarly, 3 is common here, we have to remove that. We have to multiply these values. So now simplification, x cube upon 729 plus 2x square upon 27. The simplification, 3 common plus 3 common, 5x upon 3 plus 20 plus 15 9s are 105, 135 upon x plus 6 into 81, 486 upon x square plus 729 upon x cube. So this is how you expand the fourth question, root x upon 3 plus 3 upon root x the whole raised to 6. Let's move on towards the last expansion of this tutorial. Fifth sub question, a upon 2 minus b upon 3 whole raised to 5. Because the power is 5, the fifth level of Pascal's triangle, the coefficients will be 1, 5, 10, 10, 5, 1. The first term here is a upon 2, so a upon 2 raised to 5, a upon 2 raised to 4, 3, 2, 1, 0. The second term is b upon 3, so b upon 3 raised to 0, 1, 2, 3, 4, 5. And because there is a negative sign in between, the first term will be positive, the second will be negative, positive, negative, positive, negative. What we are going to do now is simplify these terms here. A upon 2 raised to 5 is a raised to 5 upon 32 minus 5 a upon 2 raised to 4 is a4 upon 16 and b upon 3 plus 10 into a upon 2 raised to 3 is a cube upon 8 and b upon 3 square is b square upon 9 minus 10 a square upon 4 and b cube upon 27 plus 5 a upon 2 b raised to 4 upon 81 minus b raised to 5 upon 243, because both of these are 1, so we can just ignore it. Next, we are going to rewrite these terms in a simplified manner. A raised to 5 upon 32 minus 5 into a raised to 4b upon 16 3s are 48 plus. Now you can cancel out 2 from both of these, 10 and 8, so 5 and 4 will be remaining, so 5 a cube b square upon 4 9s are 36 minus, again you can cancel out 2 from both of these, 5 a square b cube upon 2 into 27 54 plus 5 into a b raised to 4 upon 81 2s are 162, and this last term is as it is. So my dear students, this is how you expand these specific terms. In my next tutorial, we will be discussing the practical sums where actual values are to be found out rather than just writing this a, b and x, y. So stay tuned for this next tutorial. I hope you like my video. Give me a thumbs up. If you are new, please subscribe to my channel, and in case of any comments, put them in the below comment box. Thank you very much for being with me, and I will see you next time. Welcome students to With Answers Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.